Welcome back. This is week 11 of the 2026 Bluewater Auto Restoration Podcast.
It is so great to be here again for this.
Yeah, and it is a beautiful Saturday morning. I am honestly just thrilled you decided to kick off your weekend with us.
Yeah.
Because we release new podcasts every Saturday morning, so whether you are currently underneath a chassis, getting your hands dirty out for a run, or just sitting back with a hot cup of coffee, we are glad to be in your ears.
Absolutely. And frankly, week 11 brings us to a topic that I think is going to, really surprise a lot of people.
Oh, completely. We are doing a deep dive today into sustainability in classic auto restoration. And it's one of those subjects where the common wisdom might actually be entirely upside down.
Yeah, it really challenges some serious preconceptions.
It does. And before we really get into the nuts and bolts of it, I have to mention that this information is presented by Bluewater Auto Restoration. They are the absolute experts in this field, and they are the reason we can go this deep into the industry.
They really know their stuff.
They do.
Yeah.
And if you want to see exactly what we are talking about today, you need to visit the BluewaterAutoRestoration.com website. But for now, let's get right to the hook. I want you, the listener, to picture the ultimate villain of the modern environmental movement.
The villain. Okay, I like where this is starting.
Right. Picture a classic car, just a big, heavy American V8 muscle car from, say, the late 60s. It has massive chrome bumpers. It smells heavily like unburnt gasoline, loud exhaust, and it's maybe getting 8 miles to the gallon on a good day.
Oh, I have the image clearly in my head. It is a glorious machine, but I definitely see where you're going with this.
Yeah, because if I asked the average person on the street today, is that car good for the environment? They would probably laugh right in my face.
Oh, without a doubt.
They would say it's a gas guzzler, a dinosaur, a rolling pollution machine that belongs in a museum, not on the road. But today we're going to challenge that exact assumption. We're talking about the paradox of the green gas guzzler.
It is such a fascinating paradox to unpack, and it really it forces us to completely rethink what the word sustainable actually means in the real world.
Right, because we've been conditioned, haven't we?
We have been conditioned by advertising to focus entirely on tailpipe emissions, just looking at what comes out of the back of the car while it's actively driving down the street.
And if you only look at that one metric...
And sure, a classic car looks like an environmental disaster. But if you zoom out, if you look at the entire life cycle of a vehicle, the physics of manufacturing, the longevity of the materials used, and the very concept of repair, well, the math changes drastically.
And that is the exact aha moment we're chasing in this deep dive.
Yeah.
The idea that the absolute most sustainable vehicle might actually be the one that already exists. We're going to unpack a concept called eco-durability. And I just love this term because it strips away all the marketing buzzwords. It strips away the greenwashing and looks at the hard physical reality of keeping a machine running for 80 years versus buying a brand new, supposedly green, disposable one every 5 years.
Yes, stripping away the marketing is crucial here. Today, we're going to talk about the stewardship of steel, why repair always beats replace, and the incredible, almost sci-fi, high-tech innovations happening in these restoration workshops right now.
Yeah, things like water-based paints and even 3D printing unobtainable parts.
Right. And we are definitely going to get into the powertrain debate.
Oh, a controversial one.
Very controversial. To swap or not to swap? Do you rip the heart out and put an electric motor in a classic car? Or do you run the original engine on synthetic fuel? It's a huge topic with very strong, very vocal opinions on both sides.
It really is.
Yeah.
And finally, we will touch on the human element today. The actual manual skills required to keep these things alive.
Yeah.
Because if we lose that mechanical knowledge, the entire sustainability argument just falls apart completely.
It really does.
So settle in. And remember, our podcasts are available on Spotify, YouTube, Apple Podcast, or SoundCloud. But let's jump right into section 1 here, redefining sustainability and looking at preservation versus production.
Let's do it.
Okay, so let's start with the really big picture. You mentioned just a minute ago that we usually only look at tailpipe emissions. But looking at the life cycle reality emphasizes something entirely different. What does that actually mean in the context of a car? Because I think most people really do just think about the gas pump.
Well, you have to think about what it actually takes to build a modern car today. A brand new vehicle doesn't just magically appear out of thin air on the dealership lot.
Right.
It requires a massive, almost incomprehensible amount of raw material extraction. We are talking about digging massive open pit mines for iron ore to make the steel, mining bauxite for the aluminum components, digging up copper for miles and miles of wiring harnesses.
And modern cars are basically just rolling supercomputers now, right?
Exactly. So now we're also mining rare earth metals. We are talking lithium, cobalt, neodymium for all those touch screens, the sensors, and especially the massive battery packs.
And that mining isn't happening in the backyard. It's a massive global operation.
It is a staggering global logistics chain, and every single step of that process burns energy. You have the diesel-chugging mining equipment, the incredibly energy-intensive refining of the raw ore, the global shipping on massive freighters to move those raw materials to factories across oceans.
Just moving dirt around the planet.
Exactly. And then you get to the actual manufacturing. High-energy processes like casting engine blocks, the immense hydraulic pressure for stamping body panels, the extreme heat required for molding safety glass and baking on the paint.
So by the time it gets to the buyer,
By the time a new car rolls off the dealer lot, before its tires have touched the road or it has driven a single mile, it has already generated a massive carbon footprint.
it's like it's born with a giant heavy backpack full of carbon.
That is exactly the right term for it. It is called a carbon debt. Some life cycle analysis studies suggest that the manufacturing phase can account for a huge percentage of a vehicle's total lifetime carbon footprint.
Oh.
Now compare that heavy backpack to a classic car, let's say a beautiful 1965 coupe. That car was built decades ago. The energy used to mine that specific steel, to cast that heavy iron block, to stamp out those sweeping fenders, that energy was spent in 1965.
So that account has effectively been settled.
Exactly. That carbon debt has been fully amortized. It's paid off 50 or 60 years ago. The Earth's atmosphere has already absorbed that impact a long time ago. So by actively keeping that specific car running, you are entirely avoiding the massive spike of new production.
It really makes sense when you put it like that. It's like the difference between buying a high-quality, reusable stainless steel water bottle and keeping it for 10 years versus buying a new, quote-unquote, eco-friendly, biodegradable plastic bottle every single week.
That is the perfect analogy. The single strongest sustainability argument in the classic restoration world is simple and completely factual. Restoring an existing vehicle completely avoids the severe environmental cost of manufacturing a new one.
Even if the restoration process itself takes some energy, right?
Right. Even if you are using electricity for welding, spraying new paint, shipping a few parts across the country, the energy consumed in restoration is orders of magnitude lower than building a complex 3,000-pound machine entirely from scratch.
But we do have to be a little careful here, don't we? Because there's a whole lot of greenwashing in the auto industry right now. I see ads all the time that makes some really questionable claims about sustainability.
There is a ton of it, and we absolutely need to call it out. Greenwashing is when a company uses vague marketing jargon to make something sound environmentally perfect when it really isn't.
Like what?
Well, for example, claiming a 50-year-old car is zero emissions just because it's a vintage classic. That is objectively false. It's not zero emissions. It's an internal combustion engine. It burns fossil fuel, and it puts carbon into the air.
Right, or saying that because you used a green plant-based cleaner on the leather dashboard, your whole shop is somehow single-handedly saving the planet.
Exactly. Or buying cheap carbon offsets to pretend a terribly inefficient process is somehow green. True sustainability in the restoration context isn't about those superficial marketing claims.
So what is it about?
It is about extended longevity and the rigorous conservation of resources. It's about being honest and admitting the trade-off. Yes, the classic car burns gasoline, but by keeping it meticulously maintained and on the road, we are preventing the waste of thousands of pounds of raw steel, aluminum, and plastic that would occur if we just scrapped it and bought a new car.
I really like the way you framed that. It's about honesty in the math. Now, one of the key concepts we need to explore here is the circular economy. We hear that buzzword a lot in tech circles, but how does it actually apply to, say, a rusty old pickup truck?
Well, the circular economy is the direct opposite of a linear economy. A linear economy is what we mostly have today. It's take, make, use, dispose. You buy a cheap plastic poster, it breaks after 2 years, you throw it in the landfill, and you go buy a new one.
It's straight line to the garbage dump.
Right. But a circular economy actively keeps resources in use for as long as physically possible. Classic auto restoration is, by its very definition, a circular practice. It is basically high-level recycling.
Because you aren't just recycling the raw metal. You aren't just crushing the truck and melting it down to make soup cans. You are recycling the actual function and utility of the car.
Exactly. You are preserving all the engineering complexity and the design utility. And this philosophy goes much deeper than just the chassis or the body shell. Think about the individual parts. A huge, huge part of restoration is sourcing and using salvaged parts, carefully refurbished components, or what we call MOS.
Wait, let's define NOS real quick for the listener who might not be a hardcore gearhead.
Sure. NOS stands for New Old Stock. It refers to original factory parts that were manufactured decades ago, but were never actually sold to a customer. They have literally been sitting on a dusty shelf in a warehouse somewhere for 50 years.
Just waiting to be found.
Right. And when we hunt down and use those NOS parts, we aren't asking a modern factory to fire up a production line and burn energy to make a new part. We are using something that already exists in the world. This actively keeps waste out of landfills and directly reduces the demand for new manufacturing lines.
It's like a mechanical treasure hunt that genuinely saves the planet. And this whole mindset contrasts pretty sharply with modern car design, doesn't it? I feel like modern cars are almost purposefully designed to be disposable.
It is the fundamental difference between a philosophy of longevity and a philosophy of disposability. Classic cars were literally built to be rebuilt.
Yeah, you can take them apart with standard hand tools.
We really can. A mechanical carburetor can be taken completely apart on your workbench, meticulously cleaned. You put some new paper gaskets in it, and it works exactly like new. An old alternator can have its copper coils rewound.
And a modern car component.
Often, it's a sealed black plastic box filled with microscopic electronics and proprietary software. If one tiny capacitor inside it fails, you cannot open it. The manufacturer doesn't want you to open it. You throw the entire expensive module away and buy a new one.
Planned obsolescence.
In many ways, yes, it functions exactly like planned obsolescence, but a heavy cast iron engine block from the 1950s, a good machine shop can bore those cylinders and rebuild that same exact block 3 or 4 times over an 80-year period. That is a massive success story for true sustainability.
That is incredible. And that segues perfectly into our next section here. We've talked about the big picture life cycle, but now let's talk about the actual physical stuff the car is made of. This is section 2, the stewardship of materials.
This is where we get into the actual physics and chemistry of the materials themselves. We touched on heavy materials like steel and iron just now. And yes, we have to admit that initially they are extremely energy intensive to create. Smelting iron ore into steel requires an incredible amount of heat and coal.
But the core argument in this deep dive is that the extreme durability of those materials ultimately justifies that initial upfront cost.
Correct. Steel, heavy iron, brass, solid aluminum. These dense materials have incredibly long, useful service lives. They can take decades of abuse. And importantly, when they finally do reach the end of the line, they are infinitely and fully recyclable.
So if a part is truly dead, it isn't garbage.
Not at all. If a steel fender is crushed and truly beyond all repair, it can be easily melted down and become brand new, high-quality steel with zero loss of structural integrity. Now, compare that heavy metal to modern automotive composites and plastics.
Oh man, plastic just degrades so badly. It gets super brittle in the sun. You touch a 20-year-old plastic door handle and it just snaps off in your hand.
Exactly. UV light absolutely destroys plastics over time. And worse, plastic is notoriously difficult to recycle effectively. When you try to recycle mixed automotive plastics, it is usually downcycled.
Meaning it becomes a lower quality product.
Right. It becomes park benches or speed bumps, but it can rarely become a high-stress car part again. But that cast iron block, it is essentially forever if you maintain the oil. It doesn't break down and degrade at a molecular level the way a plastic dashboard does in the hot sun.
Speaking of dashboards, let's move inside the cabin of the car. We have some really interesting notes from the deep dive here about interior preservation. There is a term used called eco-durability. What does that actually look like when you're sitting in the driver's seat of a classic car?
Eco-durability inside the cabin is all about conscious, deliberate choices. When you are restoring an interior or just maintaining an original one, the raw materials you choose matter immensely. It really highlights the importance of using high-quality spun aluminum for trim instead of chromed plastic, and using certified heavy-duty textiles or leathers that can actually stand up to decades of friction and sunlight.
Right.
But really, the most profoundly sustainable act you can do for an interior is just basic protection.
Protection, you mean like throwing cheap seat covers over everything?
Well, in a sense, yes, protecting from UV rays is huge, but I also mean routine care.
Hmm.
If you actively protect the leather seats with good conditioners, if you oil the wood trim so it doesn't crack, you prevent premature wear.
I see.
Because if you don't ever have to replace the seat leather simply because you took 5 minutes a month to maintain it, that is a highly sustainable act. It directly prevents the need to harvest a new cowhide, use harsh tanning chemicals, and ship heavy foam and leather across the globe.
It's the old ounce of prevention is worth a pound of cure logic.
It is exactly that. And there is a fascinating concept mentioned in this area called durum umbra.
Durum umbra. Okay, what is that?
It translates roughly from Latin to hard shadow or lasting shade. But in the context of industrial design, it refers to a philosophy of timeless aesthetics. The core idea is to completely avoid fashion-based obsolescence.
Oh, this is huge. You know how in modern fast fashion and even in modern car design, things go completely out of style in like 3 years?
Yeah. Oh, yeah. You look at a luxury car from even 2015, and the massive, clunky infotainment screen in the dash makes the whole car look ancient. It dates the vehicle immediately and makes the owner want to trade it in for a newer model.
Exactly. That visual obsolescence drives massive consumption. But if you design interior accessories with a timeless aesthetic, think of the clean, analog dials of an old Porsche or a classic Mustang. They never really look old.
They just look classic.
Right. You never feel that strong psychological urge to rip them out and replace them just because they look dated. That is a massive, often overlooked part of sustainability. Fighting the psychological urge to upgrade for purely aesthetic reasons.
I really love that concept, umbra. It sounds a little mysterious, but it's actually an incredible practical way to live. So we have covered the heavy metal chassis, we have covered the durable interior. Now let's move to where the actual magic happens. Section 3, the green workshop.
Yes, this is where high-tech truly meets old-school craftsmanship. Because let's be perfectly honest, traditional auto body work has a very well-earned reputation for being an incredibly toxic process. Yeah, I mean, anyone who has been near an old paint shop knows that smell. Heavy solvents, nasty fumes, fiberglass dust everywhere. It's not exactly a health spa in there.
Not at all. Historically, automotive paints, primers, and clear coats were absolutely loaded with VOCs.
Volatile organic compounds.
Exactly. These are harsh chemicals that evaporate into the air as the paint dries, and they are terribly harmful to both the Earth's ozone layer and to the human respiratory system. The old lacquer paints from the 50s and 60s were particularly brutal.
But the restoration industry is shifting heavily away from that now, right? I'm seeing a lot more shops bragging about using water-based paints.
It is a massive industry-wide shift. Modern high-end workshops are aggressively moving to advanced water-based paint systems and powder coatings for chassis parts. These modern waterborne paints provide the exact same durability and sometimes even better UV resistance and incredibly vibrant finishes, but they do it entirely without the toxic solvent emissions.
That's amazing, because it used to be that water-based paint was considered kind of a joke, right? Like it didn't hold up.
Yeah. 20 years ago, it was considered inferior by traditional painters. But the chemical technology has absolutely caught up. And it's not just the chemical makeup of the paint itself, it's also the hardware used to apply it. I'm sure you've heard of HVLP technology.
I have, but can you break down what that actually is for us?
Sure. HVLP stands for high volume, low pressure. In the bad old days, paint spray guns used very high air pressure from the compressor. You'd pull the trigger, and a massive, violent cloud of atomized paint would come blasting out at high velocity.
And most of it probably bounced right off the car.
A huge percentage of it did. A lot of the paint just blew right past the fender and hung in the air. That's called overspray. It was literally wasted, expensive paint, and it was terrible pollution for the painter to breathe.
So the shop was basically paying good money to paint the air in the booth.
Exactly. HVLP guns solve this by using a much lower air pressure to gently transfer a higher volume of paint directly onto the metal panel. It dramatically reduces the overspray cloud, which means far less toxic waste, less air pollution, and a much smoother, higher quality finish. It's a massive win for the shop's material budget and a huge win for the environment.
That makes total sense. Now, what about the actual shop building itself? I imagine just keeping the lights on and the air compressors running in a giant restoration barn takes a massive amount of electricity.
It certainly does, but again, modern technology is stepping in to help. We are seeing a massive push toward high-efficiency LED lighting and motion sensors in these large workspaces.
It sounds a little boring compared to the cars, but
But the numbers are huge. If you replace 50 old fluorescent shop lights with LEDs and cut your lighting energy use by 80%, that adds up to a massive carbon reduction over a year. And we're also seeing solar integration. Shops are using massive solar panel arrays on the roof to directly power the heavy restoration tools, the welders, and the compressors.
That is perfect. Those industrial buildings usually have massive flat roofs anyway. They are perfect candidates for solar.
They really are. And finally, there is shop waste management. In a modern green workshop, you can't just sweep everything into a pile and throw it in a single dumpster out back.
Right?
There is strict segregation of scrap metals, broken safety glass, and chemical fluids. These shops now partner with specialized recycling firms to safely process and recycle old motor oil, used cleaning solvents, and dead lead-acid batteries. You mentioned the circular economy earlier in the show. Well, this is exactly where it happens on the gritty ground floor.
Okay, now here is where the topic gets really sci-fi for me. 3D printing. I see that's all over the place now. How does 3D printing possibly fit into restoring a beautifully handcrafted 1920s Roadster?
Oh, this is one of my favorite developments. 3D printing completely solves the unobtainium problem.
Unobtainium, I just love that word.
Yeah.
That's the slang for the part that you just cannot find anywhere on Earth.
All
right?
right. Exactly. Let's say you are restoring a very rare 1930s vehicle, and you need a very specific, weirdly shaped mechanical bracket for the steering column. You can't just go buy it online. The company went bankrupt 80 years ago, and that part hasn't been manufactured since before World War II.
What were the old options?
In the old days, a highly skilled machinist would have to manually carve it out of a solid, heavy block of billet steel. That creates a mountain of metal shavings, which is lots of waste. Or you'd have to find a specialty foundry to cast a brand new mold and pour molten iron, which is incredibly energy intensive and absurdly expensive for one single part.
Or I guess you go out and buy a whole other rusty parts card just to harvest that one single bracket, which is incredibly wasteful too.
Exactly. But today, with advanced 3D printing, also known as additive manufacturing, the process is revolutionary. You take the shattered or rusted broken part, you use a laser scanner to digitize it in 3D, you fix the broken geometry in the software, and then you literally just print a brand new one.
And you can use modern materials for that.
Yes. You can print it using highly durable recycled plastic filaments, or even use metal sintering printers that fuse titanium or steel powder. The key here is that you are making exactly one specific part on demand. You aren't asking a factory to mass produce 10,000 of them that will just sit unsold on a warehouse shelf for decades.
It is the ultimate expression of resource efficiency.
It absolutely is. It is pure on-demand manufacturing.
That is just incredible. It really seamlessly bridges the gap between the modern digital age and the vintage mechanical age.
It really does. It keeps these beautiful historical cars on the road without needing to recreate the massive, polluting industrial infrastructure that originally built them in the first place.
Okay, so let's recap where we are. We've conceptually built the car using circular economy parts. We've painted it beautifully with non-toxic water-based paint, and we've even 3D printed the impossible missing parts. Now we have to make the heavy thing actually move down the road.
Ah, yes. The powertrain.
This brings us to Section 4, the powertrain debate. And I feel like whenever I bring this up, this is the most heavily debated, heated part of the entire sustainability conversation.
Oh, it is definitely the most polarized topic in the community right now. People get very defensive.
Because on one side of the garage, you have the massive EV conversion trend. Shops are literally pulling out the old gas engine and putting in high-tech lithium battery packs and an electric motor.
Yes, it's becoming very popular, and honestly, the initial appeal is very obvious. You get a car that looks utterly classic on the outside. It has the beautiful sweeping lines, the shiny chrome, the vintage style. But underneath, it's completely silent, it's incredibly fast with instant torque, and importantly, it has absolute zero tailpipe emissions.
Right, so you can easily drive it right into a modern city center that has strict low-emission zoning laws.
Exactly. It modernizes the utility of the car perfectly.
It sounds like the absolute perfect silver bullet solution. But there's always a but.
There is a big but. We have to ruthlessly look at the embedded energy again. Those massive battery packs are incredibly resource-intensive to manufacture from scratch.
We are back to the mining problem.
Exactly. Massive lithium extraction, cobalt mining, global shipping of heavy batteries, if you take a perfectly good, smoothly running original internal combustion engine, throw it in the scrap heap, and install a massive new battery pack, you have just artificially created a massive new carbon debt for that vehicle.
So if your goal is purely environmental, if you are genuinely trying to save the planet, the math might not actually work out in your favor if you're only driving that converted classic a few times a year.
That is the crucial variable right there.
Yeah.
Usage. How much is the car actually driven? The statistical reality is that the average classic car is driven fewer than 2,500 miles a year. And frankly, some sources say it's much less than that, maybe just a few hundred miles.
Yeah, these aren't daily commuters sitting in stop-and-go traffic for hours. They're Sunday drivers going to a local car show and back.
Exactly. So you have to do the comparative math. Compare the total annual carbon footprint of an old V8 engine that is only driven 500 miles on sunny Sundays versus the massive manufacturing footprint of building a brand new battery pack.
The battery debt is huge.
It is. The classic car's annual exhaust impact is often statistically negligible in the grand scheme of global emissions. The harsh environmental cost of mining and building the new battery for that conversion might literally never be paid off if the car is barely driven.
Plus, and I have to say this for the purists out there, for a lot of enthusiasts, the mechanical engine is the actual soul of the car. The sound, the vibration. You rip out the engine and you fundamentally lose the historical character of the machine.
That is the stewardship of history argument, and it is incredibly valid. But thankfully, there is a brilliant middle ground developing. We don't have to strictly choose between a dirty, polluting gas engine and a sterile electric motor. We have alternative fuels entering the chat.
Okay, talk to me about this. Alternative fuels. Are we talking about biofuels or this new synthetic fuel? Is this the magic gas I keep reading about?
It is getting remarkably close to magic gas, yes. So basic biofuels like ethanol and biodiesel blends have been around for quite a while now. Older, simpler engines can often run on them with just a few minor modifications to the rubber fuel lines or the carburetor gaskets.
Right, because alcohol heats old rubber.
Exactly. But the real excitement, the bleeding edge of sustainability right now, is around synthetic fuels, also known as e-fuels.
What makes an e-fuel fundamentally different from, say, ethanol made from corn?
These are highly engineered, laboratory-created fuels. They are literally created using captured carbon dioxide directly from the atmosphere, combined with green hydrogen. The core idea is that you are taking existing carbon out of the air to manufacture the liquid fuel, and then simply releasing that same carbon back when you burn it in the engine.
So it's a closed loop.
Yes, it is theoretically entirely carbon neutral over its life cycle. And the absolute best part for classic car owners, you don't have to change a single bolt on the engine.
Wait, seriously, you don't have to retune it or change the jets. You just pour it straight into the vintage gas tank.
You literally just pour it in. The complex chemistry is designed to perfectly mimic traditional high-octane gasoline. The classic car runs exactly the same. It smells the same at the tailpipe. It has the exact same exhaust note, the same horsepower. But the overall net carbon footprint of driving it drops drastically.
That feels like the absolute holy grail for this entire industry. It saves the history and the planet.
It really is the dream scenario. It is a highly practical way to keep the beautiful internal combustion engine alive and keep the mechanical history alive without carrying the heavy environmental guilt.
That is amazing. But, even without waiting for this magic synthetic fuel to get cheaper, just simple, basic garage maintenance plays a massive role in efficiency too, right?
Ugh, a huge role. Never underestimate basic maintenance. A precisely tuned engine is inherently an efficient engine. If your vintage carburetor is out of back and running too rich, you are literally dumping unburnt, raw fuel directly out the exhaust pipe and into the atmosphere.
Which hurts the wallet and the air.
Exactly. Making sure you have the proper tire pressure so you don't have rolling resistance. Using modern, high-quality, low-friction lubricants. These simple things significantly improve the fuel efficiency of older engines.
And the fluids themselves are getting better too.
They are. The modern switch to fully biodegradable engine oils and non-toxic propylene glycol antifreeze dramatically reduces the harsh risk of soil and groundwater contamination if the old car happens to spring a leak on your driveway.
So sustainability isn't just about what specific vehicle you choose to drive, but how meticulously you maintain it.
Maintenance as efficiency. I know it's a boring slogan, but it is deeply true. A poorly maintained, neglected car of any age is a gross polluter. A well-maintained, finely tuned classic is a piece of rolling history that treads very lightly on the earth.
I really like that visual. Treads lightly. All right, let's move to our final pillar today. Section 5, looking at the human element and future stewardship. We've spent a lot of time talking about steel machines and chemical fluids, but what about the actual people doing the work?
This is critical because sustainability isn't just about counting carbon molecules. It's about preserving human capital. We are in a very real danger of completely losing the manual skills required to maintain these machines.
You mean the actual physical ability to fix broken things?
Yes. In modern society, we essentially live in a replacement culture. If our refrigerator breaks, if our phone screen cracks, we just throw it out and buy a new one. We have collectively forgotten how to operate a lathe, how to safely weld steel, how to tune a mechanical engine purely by listening to the sound of it.
It's a lost art.
It is. Preserving these exact skills, what academics call mechanical literacy, is a profoundly crucial part of true sustainability.
Because if literally no one knows how to fix the broken toaster, the toaster instantly becomes trash no matter how much metal is in it.
Exactly. If we lose the generational knowledge of how to properly rebuild a complex carburetor, then eventually every single car with a carburetor just becomes static scrap metal. Keeping that practical knowledge alive through vocational trade schools, formal shop mentorships, and active restoration shops actually preserves the long-term utility of these historical objects.
And I imagine that is exactly where deep community engagement comes into play. Things like local car clubs and automotive museums.
Education and community are everything here. The role of classic car clubs, hands-on museums, and transparent restoration shops is vital in actively teaching these green techniques to the younger generation. It's entirely about passing the torch of mechanical literacy.
Now, there's also a really interesting rule mentioned in the deep dive research regarding modifications. It's called the reversible rule. How does that specific rule fit into the broader idea of sustainability?
The reversible rule is a vital concept for historical preservation. It simply means that if you choose to modify a classic car, say, for safety reasons, you want to add modern disc brakes, or maybe a better aluminum cooling radiator, or even just an electric fuel pump so it starts easier, you should always engineer that modification in a way that can be completely undone later.
So you purposely don't permanently cut the original steel frame. You don't aggressively weld things that can't be safely unwelded.
Right. You don't destroy the original fabric of the car. You preserve the option for the future. Maybe in 50 years, the next owner passionately wants to return that specific car to its exact 100% original factory state.
And if you've hacked it up with an angle grinder,
If you hacked it up, you've permanently destroyed that history. Being a true steward of a vehicle means consciously preserving the physical integrity of the vehicle for the next caretaker down the line.
that's a fascinating mindset. It's really thinking about car ownership as strictly temporary. You don't truly own it forever. You're just looking after the car for a little while during your lifetime.
That is exactly the mindset. We are all just temporary custodians of these beautiful machines. They were here before us, and they will easily outlive us if we simply do our jobs right.
That is a deeply powerful thought. Okay, we have covered an incredible amount of ground today, all the way from the massive initial carbon debt of new automotive manufacturing, down to the chemistry of water-based paint, and into the heavy ethics of swapping out powertrains.
We really have hit all the major points.
So as we wrap this up, if we had to synthesize all this deep dive information into one single main takeaway for the listener sitting at home, what would it be?
The main takeaway is that you absolutely do not have to choose between loving your classic cars and caring deeply about the planet. They are not mutually exclusive concepts. In fact, doing highly responsible, thoughtful restoration is the very definition of environmental stewardship. It is the ultimate redemption of our modern, disposable, throwaway culture.
It all comes down to those core tenets: durability, repairability, and quality.
Those are the three unbreakable pillars. If you focus your efforts on durability, repairability, and quality, true sustainability naturally follows right behind it.
I love it. And before we go, I know you always bring a provocative closing thought for us to end the show. Something for the listener to chew on over the weekend. What do you have today?
I do have one. We've spent the last hour meticulously talking about cars, metal, and gas. But I want you, the listener, to zoom out for a second. Think deeply about the fundamental philosophy of the classic car restorer.
Okay, I'm thinking.
The philosophy is simple. Fix it when it breaks, maintain it meticulously, use the highest quality materials you can find, and engineer it to keep running forever. Now ask yourself this question. If we globally applied that exact restore and maintain philosophy to the rest of our daily lives, to our disposable smartphones, our cheap kitchen appliances, our fast fashion clothes, what would that actually do to the global economy and to the environment? Just imagine a modern smartphone intentionally built to last 20 full years, engineered so that you could easily repair it yourself with a screwdriver. Imagine everyday clothes heavily designed to be patched and mended, not tossed in a landfill after 3 washes.
That would fundamentally change everything about how we live.
It would upend the entire global consumption model. And maybe, just maybe, the grease-stained classic car community actually has the perfect blueprint for a highly sustainable future. And it's been hiding in plain sight in the garage this entire time.
Wow. That is definitely something profound to think about while you're stuck in stop-and-go traffic next to a beautiful 1965 Mustang this week.
Indeed it is.
All right, well, that is a wrap for this deep dive. A massive thank you to our expert for meticulously connecting all these complex dots for us today. And remember, you can find our podcasts anytime on Spotify, YouTube, Apple Podcasts, or SoundCloud.
And please, if you want more details on everything we discussed today and to see this sustainability in action, visit the BlueWaterAutoRestoration.com website. They are the incredible team making this vital conversation possible today.
Absolutely. Thanks for tuning in and listening, everyone. Keep those old engines running smoothly, keep them clean, and we'll be right back here to see you next Saturday morning.
Goodbye, everyone. Have a great weekend.